Okay. The topic today is on the great debate on the direct current versus alternating current. This was a history already during early years. Okay, then this talk is organized by Singapore Microcomputer Society. So I'm Lim Beng Cheng. Okay, first we will talk a bit on the history of this direct current and alternating current. There was a very interesting history between Thomas Edison and Westinghouse, with the inventor behind him, Tesla. Okay, then after we will talk about explain what is DC and AC exactly. Why are they debating all these things, and what is all this issue all about? Then we will discuss the advantages of DC over AC. Of course, there are advantages of AC as well that we will also cover. But the main thing here is talk about the advantages of DC. And then we will see how we can migrate from AC to DC. A lot of these things are beyond my control. The whole world will have to migrate. Okay, then we have a discussion. Okay, first we talk about history. Thomas Edison, a lot of people know. He was famous for the light bulb. But more on this topic, we talk about DC, which is direct current. With this Thomas Edison, he has a power generator generating DC, and then they wire from the generator to the household DC current, which is about 100 volt like that. So when they want to build a power generator, which is further away from where the house is, then the distance becomes very far. So the problem with DC is they don't have the good way of increasing the voltage. But AC, they can increase the voltage. So this George Westinghouse came out with the AC. It's not that he came out, he is a supporter of AC. And then he started building AC generator, competing with Thomas Edison. Behind the scene is this fella called Nikola Tesla, which actually, if you read the history, because I wasn't born yet, so it's somewhere 1980. Thomas Edison employed this Nikola Tesla to find the problem or how to solve the problem of using DC to transmit over long distances. So because Thomas Edison isn't very good in maths, so this Nikola Tesla, he worked out the maths and then the engineering side, and then he proposed to Thomas Edison that it is better to go from AC rather than DC, because AC you can step up the voltage very high. So once you step up the voltage high, your current is low. When your current is low, your copper wire don't have to be so thick. So you can use thinner wire. Thinner wire means cheaper, less copper means cheaper. So you can send over a longer distance, cheaper and less loss. But Thomas Edison don't believe. He still want DC. So in the end, he don't like this Tesla idea. And then the history say that he not even willing to pay him because he find his idea all wash up. So and then Nikola Tesla left to start his own company promoting AC. And then this George Westinghouse came to be aware of this AC and then bought the patents from Tesla. So actually, is this George Westinghouse that is a competitor to Thomas Edison. Okay, so in 1980s onwards, in a short period, okay, this Westinghouse started building a lot of AC generator. And then to such an extent that this Thomas Edison he felt threatened that his business may be lost because of this AC. So he even have this opportunity because somebody wanted to execute a person, and then they proposed this electric chair, but Thomas Edison actually wasn't interested to do this sort of thing, to kill somebody using electricity. But because of this debate on this, whether AC is better or DC is better, then he took this opportunity to invent an electric chair to use AC current to electrocute that person, to kill the person. So he did a lot of experiment killing dogs and all these things. So in the end he made this electric chair. But the story went that a lot of journalists came to witness the first execution, but cock up because they electrocute that fella for 17 seconds, and then he didn't die. He kena shock like hell, but didn't die. So, and then they switch on the electricity again for many minutes, very long, don't know how many minutes, until that fella died. So, and then they lost trust in this electric chair. It's an anti-climax. This electric chair is supposed to electrocute the criminal, but eventually the criminal didn't die. So they got to turn on the electricity again. And then the journalists and everybody thought it's very cruel. And the fella suffered like hell in the chair. So in the end, this chair was invented, but it was not used. There's only one person executed on this chair. So, but he made a point that electricity, AC current can kill a person. But of course, even DC also can kill, but less, not so, less likely to kill. Okay, and then he also electrocute this elephant. The history said this elephant killed the caretaker, the trainer. So they wanted to kill this, but to kill this elephant, he used a AC of 6,000 volt. Your house has only 230 volt. So 230 volt can also kill you if you are not careful. You saw newspaper just recently, the family, I think 3 persons killed because of the water heater, or somewhere inside the toilet there's a leak, and then 1 person touched another person, and then 3 persons killed, and that's only 230 volt, and this elephant was killed with 6,000 volt. So it's not realistic because your house don't have 6,000 volt. So, but anyway, he just want to prove a point and dramatize the danger of AC, but he didn't win. He didn't win the debate. Okay, why Edison was so paranoid over this AC as a threat? Because in 1 year, okay, this Westinghouse installed like 50% as much as Thomas Edison had. They saw 50% of what Thomas Edison had in DC. And then the salespeople were complaining to Thomas Edison that they try to sell the DC generator. They always hit a competitor that supply AC power generator. And then it's very difficult to sell DC generator because there's this AC generator in this market that's disturbing them. So Edison has was a bit concerned. So he tried to discredit AC. So his biggest mistake is not listening to Tesla. Okay, and in 1891, this Westinghouse built a hydroelectric power from Colorado to a mine just to power the motor inside a mine. So, and in 1893, this World Columbian Exhibition in Chicago, okay, they use AC as the power generator for one of the buildings that showcase all the electrical products. And this whole building is powered by AC. So a lot of people, after visiting this exhibition, they get to know of the enormous advantage of AC. And very soon, people stop using DC already. Okay. So what is DC? DC means direct current, means current flow in one direction, like your battery. Your battery, you have a positive and a negative. So normally in this battery, the negative is at the bottom, and then the positive is on top. Same here, negative, positive. For this type, one is negative, one is positive. Sometimes I forgot which one. Okay, and then even solar panel, okay, current flow in one direction. The solar panel supply DC current. So you just plug it in and you get DC. Okay, so all these are direct current. Even you think wind generation, it may be AC because this there's a turbine turning inside. So as the wind blows, this turbine will generate electricity. But the problem is the wind blow in different intensity. So the turbine turn at different speed, and you cannot guarantee 50 hertz. But how to get 50 hertz? Because if you cannot get 50 hertz, or in some country it's 60 hertz. So let's say you talk about in Singapore, 50 hertz. If you cannot get 50 hertz, then you cannot power, you cannot plug into the grid. You cannot supply to the country because the whole country runs on 50 hertz. So the only way is you store it in DC, and then you power it. You control another generator that turn a motor. Okay, you control another motor that turn a generator in the same frequency, 50 hertz, so that you generate this AC and with the correct voltage and correct phase. So you get AC output. But basically, wind energy has to be stored because sometimes the wind is strong, sometimes it's weak. So you have to store it temporarily, and then you use it to run a motor to power a generator, a turbine, to generate electricity at the right frequency. So it is quite troublesome. So imagine if you have a wind farm, and then you only need to transmit DC, then it's very easy. You just generate DC and then send over. You don't need to bother about AC. So you find that the DC is more straightforward because it's only voltage and current, that's all. No need to care about frequency and phase and all these things. So you talk about, just look at a simple schematic. Here you have if you have plot against the voltage versus time, then it's a constant. DC is a constant voltage. Okay, the symbol is one constant line, and then with a dot dot dot. This one represent ground, horizontal ground. Then this represent constant voltage. Because you draw one line, then people catch no ball. So they have this thing. This symbol represent DC. So if you look at your adapter, sometimes you turn behind, you can see this symbol. Sometimes you you see the word DC. Okay, so they always say DC direct current, and the current flows from positive to negative. This is just a concept that they say, oh, current flow from positive to negative, because people in the early years, they don't understand electron, what electron flow, because electron always move from negative to positive. But they always think, oh, positive means higher, negative means lower. So they will consider, okay, current must flow from a high voltage to the low voltage, so positive to negative. But that's current flow lah. Current flow and electron flow are different, just opposite meaning. So now people, when you do engineering, you talk about current flow. Okay, nobody talk about electron flow. Everybody talk about current flow. So it's always positive to negative. All calculation, everything is based on current. But the direction is not that important. Okay, whether the electron flow one side or the other side, everything they work on, just have a common understanding is current. Okay, then everybody will be correct. Okay, so this is just a historical reason that they keep positive to negative. Okay, now we talk about transmission. Okay, DC transmission in just 2019, not long ago, DC reached a voltage of 1.1 million volt. This one they call it ultra high voltage. Okay, this one is from in China, that they transmit 12 gigawatts. 12 gigawatts is a lot, because your light bulb maybe only 12 watts, and giga is 1,000 million. So that's enough to power 50 million household, roughly. Okay. And the most important thing here is the distance. It travel a distance of more than 3,000 kilometers. So if you have such a distance, then you actually can take the power from the solar panel and run it 3,000 kilometers to the west. And then when your solar energy is, the sun is rising up, you can power the west side or the east side, because you are 3,000 kilometers away. So there's a time difference. So one side is hot in the day, when a lot of people are not using the electricity, only maybe factories, office are running. At home, nobody go back home, turn on the aircon. But another part of the world is maybe near evening already. When they say 3 o'clock, then some place will be darker already, 6 o'clock, 7 o'clock. So it appears darker. So they start to turn on electricity. So if you can run 3,000 kilometers, you can straight away power another city using solar. So you don't need to store the energy for the night. Your night can use another country, another city 3,000 kilometers away. I mean, something like that. But here they don't. They use a generator. They just want to pull the wire 3,000 kilometers to power another city. So this technology now, they can reach until 1 million volt. And this is a very crucial part that make DC very important. And they started to implement DC transmission now, because this one is only talking about DC transmission line. That means from one power plant to somewhere, a long distance, a power source where they generate energy, they say from a nuclear power, from a gas power or solar power, whatever power, to where is to be consumed. So sometimes the location may not be near your city where you need the electricity, because let's say nuclear power, they want to put it very far away in case there's a radiation or something wrong. You cannot close out the whole city. But if you place it too far, like 3,000 kilometers away, then it should be safe enough lah. Like if Japan Fukushima something wrong, in Singapore you don't get the effect because it's quite far away. Even Tokyo it's not affected so much, although it's less than 3,000 kilometers. So if you put your nuclear plant far away, even 3,000, 1,000 kilometers away, then your city is less affected. Okay, so but if you place them so far, in the past they can only use AC transmission, but now they can use DC transmission because the technology has advanced so well that now they can generate DC up to 1 million volt. In the past, Thomas Edison is not able to produce DC at a high voltage because they don't have good diodes, those diodes or rectifier to convert AC to DC. So there's no way for him to generate DC at such a high voltage. So if the voltage is high, then the current can be low because the power is current times the voltage. So there's no free lunch one. If you increase the voltage, then the current reduce. But both of them multiply together, you get the same value. So if you, for example, if you have 1 million volt, then your current is say 1 ampere. But if you reduce to 1,000 volt, then your current become 1,000 ampere. You see, but 1,000 ampere of current will require 1,000 times thicker wire than 1 ampere. You see what I mean? So it's cheaper to increase the voltage because you only need to have one equipment or device to increase the voltage. But your transmission line runs thousands of kilometers. So it's definitely worth it to increase the voltage. Okay, and then if your wire is shorter, then your wire is thinner, then it's cheaper to install, lighter. You don't hold a very heavy wire on your pylon. You don't build a tower to hold a very heavy wire, and then if long distance, a heavy wire will sag, and it's very difficult to handle. So DC in this sense, with a high voltage, is definitely beneficial. Okay, and especially when it's underwater. Underwater, there are a lot of other issues like inductance and capacitance, because water is a good dielectric, and then when the current flow between the wire along the wire and there's a water in between, there's actually some electrical energy being lost in between the two wires between the water. So this one is induction loss, capacitance loss, and all these things. But in the air is not a very good dielectric. So you don't need to put it so far away. And water, you need a lot of other insulation and so on. And you find that if you want to install more than 800 kilometer, it's definitely not worth it already. Even 500 kilometer is probably cheaper to use DC. You see, and in the long term, your losses will recover back if you use a higher voltage. Okay, and there's these two companies like ABB and this Siemens. They are very advanced in DC. So they are really collaborating with China on R&D. And it's only China that can use such a high voltage and long distance, because China has a big land. Of course, you say US also has a big land, but US to cross from one state to another state, then there's a political things you need to debate like hell. Even India, from one state to another state, then they will have to debate already who to get what, how much the state will benefit, and all these things. A lot of politics inside. So only China don't have this type of politics. So and the other problem is on the electronics, the semiconductor. You see, US sanctioned China, but China is very good in this area of power electronics, because this power electronics semiconductors, probably the US didn't think is something very important. They are looking at nanometer and all these things for the computer microprocessor, all this, but they didn't protect all these high power electronics. They're not so particular because, and this technology is more or less quite mature technology used in power electronics. So now and China acquire all these considered old technology, and now they are very useful. All this power electronics is now very useful because everywhere they are using all the solar panel. All those people, they are using solar panel, and then wind power, and all the DC generators. So power electronics is becoming very important. You put a solar panel, you need to buy inverter, you need to buy other things, all these electronics, high energy, and China is quite advanced in this area of power electronics. And now they are working with ABB and Siemens, and these are not a US company, they are Swiss company. Okay, so what are the advantages of DC versus AC? Okay, DC basically needs 2 wires. Okay, one direct current, 2, and then the current come back. So 2 wires. You look at your battery also 2 wires. 1 positive, 1 negative. That's all. Whereas AC 3 wires. A bit later we will explain why 3 wires. Because they run in 3 phases, so that it's more economical to run. In the early years of AC, they only have 2 wires, so you run 1 phase only. But they find that to power a motor, if you run a 3-phase AC and then you power a motor, it's more efficient. The motor naturally has 3 phase, just like those now electric car also run with 3 phase, but they need to convert DC to 3 phase to power the motor. So it's more or less 3 phase, then you need 3 wires. Okay, and then if you use for transmission, here we're talking about transmission. For transmission, DC has almost no induction loss. Induction is a coil. So when you have a coil of wire, and then when you pass current through it, so it will produce magnetism. Okay, of course, a single wire, a straight line wire, also have induction, but it's less. But if you pull a single wire over very long distance, then it will produce inductance. Little bit multiplied by 1,000 kilometers is a lot. So all this inductance loss appears only in AC, because the current go up, down, positive, negative, and then you need to switch. So the magnetism need to switch here, switch there, so you create some induction. So they call it induction loss. Okay, capacitance loss means there's a two plate. Okay, so they behave like capacitance. But in a transmission, you don't have two plate. You have two wires, but two wire moving parallel normally and at a distance. You put too near, then the capacitance will be higher. So you put further away. I cannot put very far because you only have one tower. How far can you put? So you put further away, then more problem lah, because very far, then difficult to maintain. So there's a certain distance you think is good enough. But this small little capacitance over a long distance, 1,000 kilometers, will become quite significant. And there's also the earth. The earth also act like a capacitance. So it's not only between wire, also between the earth. So capacitance loss can exist only in AC because the current go up, down, up, down, up, down, and some of it lost through the capacitance of the circuitry. But DC don't have this loss because it's constant direct current. So the capacitance loss is during charging, when it charged, or during consumption. When there's consumption fluctuates, so the current also fluctuates a bit. So, and that fluctuation can create some capacitance loss, so it's negligible. Whereas the AC, the current is up, down, positive, negative, positive, where no matter how much you consume, it always positive, negative. So the loss is so much higher than a DC. So in DC, we normally consider as no loss because it's very negligible. And the other one called skin effect. When you pass electric current through the wire, if let's say if at 50 hertz, which is our AC supply, if your wire is say very thick, thicker than let's say radius 9 mm, so diameter is 18 mm. Okay, let's say your cable is very thick, okay, 10 cm, but you pass through AC through a thick cable, but only the outside 9 mm is conducting current. The center part has almost no current. This is called skin effect. So that's why when you look at your TV antenna, in the olden days, you have a TV antenna. If you hold the antenna, you find it's very light because inside is hollow. The antenna is hollow. Sometimes some people have those Yagi antenna on the rooftop or balcony. In the olden days, 1990, 1970, 80, you have antenna outside your balcony where you tilt here, tilt left, tilt right to get the right transmission. And then you find your antenna is hollow and inside is hollow, very light. The reason is because there's no point you put aluminum or copper, whatever material inside, because it has no effect, because this antenna runs at very high frequency. So the effect is only at the skin only. So that's why it's called the skin effect. So in lower frequency, the skin effect is less apparent. But at 50 hertz, the skin effect is 9 mm. 9 mm is not a lot. Okay, because there's if you count the diameter is like 18 mm. But the cable is very thick. If your cable is very thick, then 9 mm become a lot, a problem already. So you have a limit. Okay, but in DC, there's no skin effect because it's constant. So you can use thicker wire, no problem. Okay, and then DC also need less insulation because if you look at AC, let's say 230 volt AC, your house is 230 volt AC, but when you look at it, it's a waveform. 230 volt means is a heating power. So if you use a DC of 230 volt, a direct constant voltage of 230 volt, is equivalent to your AC 230 volt. But this AC 230 volt, technically they call it the RMS value. Okay, the root mean square. So this 230 volt AC is actually an alternating current that goes up to 320 and then drop down to minus 320 and then go up again, down again, up again. So the peak is 320 volt. And then the negative peak is minus 320 volt. So with this peak of 320 volt, then you need thicker insulation compared to 230 volt. You see, so it is like 50% higher voltage, because if your insulation is not good enough, it will just puncture through the insulation and then hit, and then the spark over. You see, when you see sparks flying when the two wires connect, or if your two wires are too close, then the spark will jump over to the other side. The electron jump over. So that's sparking. That means the insulation break down. So they need to cater to a higher voltage. Okay, for 230 volt, they need to times square root 2. So that's about 320. So you need more insulation. Okay, and then DC is also more suitable if it's underwater, because underwater, all the problem, induction, capacitance, insulation, all become more apparent in AC. So DC is a better choice. Okay, so for long distance transmission, DC win already. Now they already won the case and no need to argue already. Okay, and underwater, DC is the best choice. No need to argue also, because people look at the money, they know. Okay, so DC has, other than transmission, let's say you use it anywhere, like in your house or somewhere. Okay, you find that DC has other advantages, such as you don't have a phase shift. Okay, later I try to illustrate, because this is a bit technical, because when you connect to a fan or motor, then it's considered as inductive load. So there's shift. You connect to other capacitance load, then the shift will be the other way around. That's why sometimes you go exhibition that this fella, they try to sell, they say plug this device in, save energy, and they have a exhibit and show you, okay, now I turn on this device. Okay, you see they show you 2 meter, one a voltage, 230 volt. The other one is a current. They show you, oh, 10 ampere. Then when they plug in this, they call energy saver. They plug in, and then you see, I turn on the energy saver, turn on up, the current straight away drop. The voltage don't drop because it's always 230 volt. That's our AC voltage, but the current drop. See, straight away you power on, you save energy. Alamak, straight away I see this, I know it's a command job, because he's measuring current and voltage. The reason why the current drop is because there's a capacitor inside that device. That device, if you open up, is only one capacitor, one stupid capacitor, and that maybe cost you $1 only, and they sell you $100, $99, $50, whatever dollar they can charge you, and they tell you save energy. If you want, you just buy a capacitor, 400 volt, just plug into your supply. You also can get the same thing. Okay, but different capacitor will depends on your inductive load. If you are a factory that have a lot of motors running, then you can help save some energy, but not much, because the power company charge you by the watt power. Watt means the energy consumed, whereas what you consume is volt ampere, voltage times current, whereas they charge you watt. Watt is also voltage by current, but it means voltage times current in the same phase. But if your machine out of phase, then you actually don't pay for it, but it will cause a lot of problem to your neighbor's voltage, your neighbor's current, and you cause a lot of problem to the energy provider. So they don't like, energy provider don't like you to have very high inductive load and all this. That's why they always tell you you must have a power factor of a certain amount. Otherwise, your device are not approved to plug into the system. The power factor means how much phase shift your device created. So if your device shift too far, then they tell, hey, don't do that. You plug in, you disturb your neighbor and the whole Singapore. A bit 夸张 lah, not the whole Singapore lah, but at least you disturb the whole network. If everybody does that, then the power company will be in trouble. Okay. And then DC is direct current. There's only a voltage to measure. You don't have frequency to bother. Whereas AC, you have 50 hertz and 60 hertz. If you want to match the AC, then you must match the frequency exactly, exactly. If you match a bit different, then over time, there'll be harmonic distortion already. Okay. So AC is affected by noise, because noise coming also affect the AC voltage. AC, it curves up and down. So you need a perfect sine wave, go up smoothly, go down smoothly. And everybody on off, then the sine wave become some distorted sine wave. Whereas DC, if there's noise, you can easily filter out. Putting a capacitor, you can filter out all the noise. So it's not a problem. And if your device runs on DC, your device basically is not bothered about the fluctuation in the voltage. The minor fluctuation, the noise, all this will be filtered off easily by putting just a simple capacitor. They call it reservoir capacitor. You store the charge first. So it is considered less immune to noise. And then just now we mentioned the peak voltage in DC is about 0.7 times of the AC. So AC is like square root 2, is like 1.414 times the DC voltage. The peak voltage in the AC is higher than the DC. DC has no peak. DC itself is the peak. Okay. So if you have a direct current, you can easily control it by a diode. You put a diode, so current can only go one way. You cannot pump the current the other way around. It won't go through. So you can isolate the circuit. You want to draw the current, you just put a diode, the current come in. So whatever you do inside, you have a battery, you have generator, whatever, it will not affect the outside. So a diode, simple thing, just put a diode. All the electronics, your phone may also have a diode. So if you charge the wrong side, if you're wire wrongly, you just cannot charge. The system don't work. You see? Okay, here is an example of some technical thing. If you don't understand, it's okay. This is called AC lah. Go up, down is called AC. Okay, and then this from one cycle, you call it 360 degree. One cycle. Okay, that's something like maths. And then this curve is called a sine wave. Okay, if you study maths, sine, cosine, tangent, this is a sine wave. Okay, if you have distortion, then this wave will look crooked. That's harmonic distortion. Noise coming will add to it. So in real life, you won't see a perfect sine wave. This a pure sine wave. Okay, no distortion, nothing. Only representation is like that. In real life, it's never like that. Okay, so if you look at this, okay, this is a voltage curve, and then the current they put I lah. Okay, this symbolic only. I represent current. Okay, so you find the current is behind. Okay, so this is an inductive circuit. So as the voltage go up, the current try to catch up. So if you have a motor, you find that the voltage go one side, your current come at different rate. Okay, but the power consumption is the voltage times the current. So at this point, the voltage is 0. So you times the current. So you get power 0, no power. Okay, over this point, also 0 current times the voltage, you also get 0 voltage, 0 watt. Okay, no power. So here you multiply, there's some power coming up, then go down to 0. And then here the power will go up again. And then here also go back to 0, no power. Okay, and then you go up again, and then come down 0 again. Then go up again, come down 0. Go up again, come down 0. Go up again, come out 0. So, but somebody has to pay for all this current. No? This current travel all the way from the power station to your house, but nobody use, and then you send back. It went one round from power station to your house and back to the power station. So along the way, this current will be heating up all the wires along the way, and somebody got to pay for it. All these are losses. So inductive circuit is very bad for the company because a lot of current flow, but didn't generate money for them. So they don't like. If your circuit is very inductive, they ask you, hey, don't connect. Okay, or they somehow they don't like this type of inductive thing. And then if your neighbor also like that, then it will affect your computer system, your everything. So people, there's a big job behind trying to maintain these two to be in phase. Okay, many engineers are monitoring this. So if you have a resistive circuit, then your voltage go like that, your current follow. Okay, whether the current more or less is okay, because they are measured in different scale. The current is measured in ampere, the voltage is measured in voltage. Okay, volt lah. So they are in different scale, but they draw it different height for illustration purpose, so that you can see. Then they draw all the same, then it doesn't look like a graph. It looks, you don't catch the thing. So you ignore the height. Okay, just look at the phase. So it goes at the same phase. This is a resistive load. Okay, for example, resistive load, you can actually say things like a TV, your computer, all these are considered like resistive load because you don't have a motor. Okay, basically okay, but no device is 100% resistive. Only your kettle, your heater, because these are heating elements, so they are considered resistive load. Okay, other than that, they are more or less not. But computer, all these can consider. But your fan, your refrigerator, motor, all these are not. They are considered inductive load. But of course, they will put some capacitance there to compensate for the inductance, so as to pass. Otherwise, the power station will tell them, you don't sell this device in this country. Okay, not allowed, because it will affect the power factor a lot. But behind the scene, they tell them don't do that. But when you buy, you don't even notice all these things. You just buy and plug in. Do you care? You don't care. But it's the power company that cares. So here we look at the phase. This is in phase. In phase means in the same phase. Okay. So this is roughly a very rough diagram. Okay, this is AC transmission. You notice AC is 3 wire. Okay, because they transmit in a delta format. They have 3 phase, 1, 2, 3 phase. So the power generator is somewhere here. You generate the power and then you transfer over long distance. And then at the receiving end, they put another transformer that is different type, wires like that. So you end up with 4 wires. So if you own a factory or you have some office space, sometimes they have a 3-phase power supply into your office. So you'll find that there's 4 wires. One is neutral, one is live, and so on. And it's very important that these people connect correctly, because let's say one pair, one live and one neutral. This one pair, it goes to one of the floor in your 3-pin power plug. Then another live wire with another neutral go to another floor, another 3-pin power plug. Some people who live in landed property, they'll realize that the home has 3 phase. One for the ground floor, one for 2nd floor, and one for the 3rd floor. Okay, sometimes if they have only 2 floors, then the ground floor have 2 phases, one for the ground floor in front, one for ground floor behind, and one for the 2nd floor. Or how they wire, I wouldn't, it's up to them. But basically, you may have 3 phase. But if you stay in a HDB flat, condo, or some apartment, then you will probably have only 1 phase like that. So one phase. So one floor may get 1 phase, another floor may get another pair, the neutral and another live wire. Another floor get another pair, another live wire and another neutral. So they hope that everybody, okay, eventually everything will even out evenly. If any of these phases are uneven, then it affects the transmission, because it's the supply side. They'll try to supply evenly. The motor will turn at the same speed. You just turn constantly round and round and round. So the voltage, the power is always the same in every phase, but the consumption is different. So all this can create trouble for them. So they will try to even out as far as they're concerned, as long as the whole Singapore, everybody use it unevenly, but eventually it evens out. So it's okay. Okay, so they are happy with it. Okay, in the factory, they have 3 phase. So they run motor, because factory are expected to maybe run a lot of motor generator, or all sort of funny motor, like lathe machine, or the big machine, or compressor. So they need a 3-phase motor. So you have a 3-phase power supply is easier. Okay, so if you take a look at the transmission line, okay, without looking at how many wires they have, then assuming this generator is 12 kilovolt, okay, and then you send over, you use a step-up transformer. In AC, it's very easy to use a step-up transformer. This step-up transformer is just a coil of wires. Okay, and it is almost maintenance proof. It has no moving parts and it lasts very long. It probably unlikely to break down. So it's very, very reliable. So it's only AC that you can use this type of thing called step-up transformer conveniently. That's why in the past, in the 1880s, Westinghouse won the AC game, because DC, you cannot step up like that. There's no easy way. Of course, today we have a lot of power electronics. You can do a lot of things. Whereas in the past, they don't have this technology. So they only have is a transformer. So transformer can easily step up and step down. So here they step up to 400 kilovolt, and then they can send over very long distances. Okay, although here they show very short, but you can be very long, maybe a few hundred kilometers. Okay, but of course, the higher the voltage, then the thinner the wire is better. Okay, and then after that, when you reach the destination, then they'll step down again. They step down back. They say step down to 13 kilovolt, and then when it's near your house, then they'll step down further to 230 volt, 240, depends on country. This one was copied from somewhere. So let's say step down 230 volt, then go to your house. But some in even in my office, when I measure, it's not 230 volts, it's sometimes 240. So when they step down, they try to step down also a bit higher in case everybody is using. So the voltage will drop. If a lot of people use, then the voltage will drop a bit. So if they put exactly 230 volt, and then the voltage drop, then they call it brown out. Brown means not enough. You don't have enough power. Let's say drop to 180, then your light start to become dim, and then the computer may say, "Hey, how come the voltage get too low?" And then you cannot regulate the voltage properly, and then something go haywire already. Okay, but as far as electronics nowadays, you can stand 110 volt up to 230 volt. So even if your voltage fluctuates a bit, up down, it still work lah. As far as you're using a computer, you don't notice it. Okay, but if you are using, let's say in the olden days, they use incandescent bulb. Then sometimes when the neighbor turn on the power on the refrigerator, then you find your light will blink a bit. Or in a factory, and then when somebody turn on the big compressor, then suddenly you'll find your light will blink a bit because the voltage, the load is very high. So you bring down the voltage for the time being, a short period. But with all these electronics, you don't notice it nowadays. Okay, so this is how they step out the voltage, transmit, then they step down. Okay, now you look at the transformer. Okay, you can have a small little AC transformer about this size. Okay, maybe various sizes. Some are very small, like 1 cm square. Some can be bigger, let's say 10 cm. But you look at the real large power station transformer is as big as your house. So this they have a different purpose. They have very high power, high current, and all this. So and you notice when this transformer, all the wires they are purposely spaced very far away because it's very high voltage. You put too near, arcing the electric arc will jump across. So and it's very dangerous. You don't go near this style of transformer. That's why a lot of places they already barricade it, put fences and all these things. They don't want people to go near. It's protected area. Actually, to protect you, you go near the arcing, the electricity may run to your body. So it's very dangerous. These are very, very high power. Let's say 13 kilovolt or 400 kilovolt for some places. See where you are. But I doubt you can get even near to it. So you unless you deliberately go near, it's very dangerous place. All this transformer. Okay, basically how a transformer work. Okay, so you half the number of turn over here. Okay, this has a certain turn, let's say 220 volt. Then here you got half the number of turns, then you get half the number of voltage. Okay, and then if you, of course, you double the turn. If you run the voltage here, 110 volt come in, and then your output become 220 volt. If you flip over, 220 volt come in, your output become 110 volt. So you step out or step down depending on which side you go in. So if you use let's say those electric racket that you use to catch mosquito, okay, so or those taser, they also use something like that. Okay, of course they have electronics behind it to do a very high switching speed, and then they can afford to use a very small little transformer with a high switching speed, and then they can increase the voltage very, very high to 10 kilovolt, but it won't kill you. It gives you a very nasty shock. those taser that they fire at, the police used to fire on criminals or people, and then they give you a shock, and if it actually freeze your all your muscle, and then you cannot fight back. So in order to protect yourself against taser, if you want to encounter police, I suggest you wrap yourself with aluminum foil and then wear your clothes on it so they can't see you with the aluminum foil. So if they shoot the taser at you, the taser gets short-circuited by the aluminum foil and you won't get affected. Although the taser will punch 2 holes into your body. They have a 2 pin, 2 sharp pin, like a fishing hook like that. Then it will plunge and it will hook into your body so that you won't drop off. Otherwise you struggle and you fall down, the thing drop off, then no more electricity, then you can run again. So it has a small little hook like a fishing hook. Then you stuck to your flesh. But because you have aluminum foil, the current will go through the aluminum foil, it won't hurt you. And you can still run away, even you cannot taser. Okay, but for the mosquito, not so easy because you have an electric racket. You hit the mosquito get electrocuted. And then if you use that to Zhang must mute him. Okay, so if you use that to hit your friend, let's say electric mosquito killer, to swap mosquito, you use that to hit your friend, then your friend get electric shock and quite painful. Okay, but it won't kill because the energy is not enough to stop the heart. It's just enough to give him a shock. Okay, so that is how you can step up and step down voltage. Okay, but of course, you find that you can, if you input 110, then you get 220 volt. You find that I got more voltage, means I got more energy. No. Voltage is not energy. Voltage means it's like pressure, like water pressure. Okay, you put the bucket higher, the bucket is higher, then the water flow down faster, stronger. Okay, so voltage is not energy. Okay, energy is voltage times the current. So if you connect equipment at the 220 volt, let's say you put a kettle and you put a computer that draw 1 ampere. So 220 volt times 1 ampere, you take 220 watt. Okay, and here it has to pump in 2 ampere. Here, 110 volt, you have to pump in 2 ampere. So there's no gain, no loss. Here you take 1 ampere out because your voltage is 220 volt. Here you need to pump in 2 ampere because your voltage is half. But if you cannot pump enough 2 ampere, then you will not able to get 1 ampere out. Okay, it's just like that. Not enough power supplied, and then definitely nothing come out. Not enough will come out. Okay, so there's no such thing as free energy. Some people, they thought, oh, I double the voltage, I double the energy, free one, no need the same input. But I forgot the water you need to supply is 2 times more. Okay, so you look at your home. Your home is mostly DC. Okay, your LED lighting is also DC. But why you buy your light bulb, they call like 230 volt AC, is because your house is AC. So the light bulb has to deliberately design to convert your AC to DC to power the LED. But if your house is already running on DC, then you don't need to have extra circuit to convert AC to DC. So your light bulb will be a few cents cheaper. Yeah. So is already natively is DC, but because every house is AC, then they got no choice but to add a circuit to convert AC to DC. So LED light you will save on LED light. Okay, and then your TV is electronics. TV, computer, phone, and all electronics, they are all running on DC. Okay, all electronics are DC. So, but why you plug your computer to the AC power? Because that's the only power source is AC. But when you plug in, there's an adapter. The adapter will convert the AC to DC. And then your computer runs on DC, that's all. So you're extra, you do extra work converting AC to DC. Okay, so those devices that are already AC, you can run with DC without problem, are those like heater. If you have a heater that runs on AC, you just put DC, it will work as well, because these are just heating element. So no difference. Okay, some may have a different, like a refrigerator, washing machine, fan. All these are actually can you see the motors are designed for AC. Okay, but some of these refrigerator, washing machine, or fan, the motor can be changed to a DC motor. So you can also run them. There are refrigerator that are 12 volt operated. So behind you can switch AC to DC. Then you can power on 12 volt or 24 volt. So you can use that on in a solar, using a solar power. Then you can just straight away power your generator, your refrigerator. You don't need to use convert the solar power to AC, which will waste energy. Okay, then washing machine is possible to run a DC motor, but once if every house has a DC, then people will design washing machine that runs on DC. And then a lot of washing machine has a microcomputer control. All these are DC. So now they have to use AC, they have to convert to DC, and then step down, and then you get all these computer controlled washing machine. Okay, same for fan. So of course, if I have the choice, the chance, then I will propose to wire the home in DC. So for convenience, 400 volt DC will be a good choice. Of course, it will be dangerous. But if 230 volt is dangerous, then 400 volt is also as dangerous. A bit higher, but not much more dangerous. And 400 volt means you need a thinner wire, so it will be cheaper to wire the home using 200 volt DC as compared to a 230 volt AC. Okay, and then the wire is not much, don't need to be much thicker. If you want to use back the same size wire, then you run, instead of 400 volt, you run at 320 volt. That will be the peak voltage of this 230 volt AC. 230 volt AC, the peak voltage is 320. So if you run 320 volt DC, then you don't need to change any wiring. Now 400 is just a nice round number. Okay. So very popular is 48 volt, 24 volt, 12 volt, and 5 volt, because this one is used in a lot of USB and is 5 volt. But 12 volt is because it's made popular because of the lead acid battery in the early years. There's the only choice of battery is lead acid battery, 12 volt. They put two together is 24 volt. Then you put four of this lead acid battery is 48 volt. So that's why this 48 volt is very popular for those with a higher voltage. I mean, those higher power device, like motor, if all those bigger motor they run 48 volt DC. Okay. So if you run your house in DC, then it's easier to integrate the solar panel because solar panel is already DC. So you charge your battery. If your battery is 48 volt, then your solar panel charge your battery 48 volt. Finish. The whole house is there. You don't need to put inverter to convert 48 volt to AC. So you use 48 volt, and if your everything is in the house run on 48 volt, then it's okay. You are fine. If everything in the house, some of things run on 12 volt or 24 volt, then you just have a step, a switching regulator, then you also can get. And if the grid is DC, then it's easier to tie to the grid in DC rather than AC. To tie to the grid in AC, you need to match the voltage, match the phase, and match the frequency. Oh, it's tough, more complicated. And then if you don't do it correctly, a lot of problem. So that's why the government don't want you to connect your solar panel to your home without approval because they worry your solar panel and your inverter may accidentally feed back into the grid. Then it affects other people. And the problem with this, our meter is, imagine AC current. So AC current is switch forward, backward, forward, backward. It's AC alternating current and the voltage also. So if your solar panel produce more energy and you use an inverter in your home or office with a solar panel, and then your inverter also produce AC, and then you try to put the two together, then if your AC become more higher voltage than the outside, then your current will be flowing back into the circuit. And first, this is illegal. Second is you pay for it. Even though you supply people, the more you supply, the more you pay. Because as far as the meter is concerned, it doesn't know that whether the current come from you or come from outside. Because AC is alternating in, out, in, out, in, out, in, out. Or positive, negative, positive, negative. So when you supply also positive, negative, so there's no way for this meter to know. Only special meter will know the difference, but your house meter will not know. So when you happily generate a lot of energy, in the end, all bill to you. You supply to people, they also bill to you. So it's not so good. Whereas DC is easier because there's only a voltage to control. So if you put a solar panel, then they don't want you to tie your solar panel to the grid. Unless you have a special grid type inverter, then you need approval. Then they get checked, make sure everything is okay before they tell you, okay, now you can connect. Okay, so if you have let's say if Singapore run on DC, then outside current passing DC, that's it. They have put a diode there to block you. Then your solar panel generate a lot of voltage. It won't go out. It's safe. Everything is inside your house. See, so you don't care what grid tie or not grid tie. There's nothing to care really. If you don't have a diode, you can put one diode also at your switchboard, and nothing goes out. So the only thing is when it's a grid tie, if the power grid is down, they also want you to shut down your system, because otherwise your system is supplying power outside to the outside. And if the service technician happened to be outside doing work, then he thought the circuit is down, it's safe to touch the wire. Then he go and touch the wire, but you are supplying the power, so you electrocute him. So that's why when it's grid tight supply, when power failure, the whole Singapore says your area power failure, you don't expect your battery to work because it's grid tight. so your battery will not work. You also get power failure. Unless you have a separate circuit where you switch off and disconnect yourself from the outside world, then you can turn on your inverter. So this is one reason. But in the DC, you don't have this problem. If the outside is down, your house still power up. If you have battery and everything, because there's a diode that block, nothing goes out. Okay, so assuming you have in my proposal of, let's say, 400 volt DC, and this DC can power a lot of things. You can power TV, you can power your all the heavy equipment, heavy consumption like your heat kettle your rice cooker your oven and all this, and the washing machine. All this can be powered even your fridge also if you want to. And then if you want a lower voltage, then you can step down the 48 volt. Okay, but you see, DC device can be designed so that it can be quite tolerant of the voltage. The voltage in DC is 400 volt. It can drop to 100 volt. You still can step down to 48 volt. No issue. You can drop up to 60 volt. You still can step down to 48 volt. So you don't have to be so paranoid over the voltage level, because AC cannot. AC 230 volt you drop, and then the electronics don't work already. If the electronics is designed for 230 volt and then you start to drop, then things stop working. Then but TV, all these can run on 48 volt. Maybe 12 volt will work. Even the computer, you can run on 12 volt. So you want to step down 12 volt, you can just step down 12 volt. Or from 48 volt, you just design a switching supply 48 volt down to 12 volt. It's simpler than a 230 volt AC and step down to 12 volt. And then the fridge can easily run on DC. You have a small DC motor, it runs easily, no complaint. And then lighting is the easiest. Now LED light, all DC. Maybe you don't even need any control circuit. If you know it's 48 volt, you just plug in, it light up already. So the LED light is unlikely to spoil because you don't need a driver circuit. Your 48 volt DC can power it. That's it. Your LED light designed for 48 volt DC, you will run without a driver circuit. Okay. So here we finish the talk. I think we finished quite early. So I shall stop here and then we shall have some discussion.
Jing,